Let's look at some examples of solving quadratic equations. Let's solve this quadratic equation. Z squared plus z minus 6 equals 0. Now I'm going to solve this using factoring, but there are several methods that you can use to solve this. So I'm hoping you do remember how to factor. I'm going to use what I call the X method. And you do also need to remember standard form of a quadratic equation means that it's in the form a times z squared plus b times z plus c equals 0. And with the x, I'm going to put my c term, which is negative 6, at the top of my x. My b term, which is the coefficient of z, which is 1, goes at the bottom of my x. And I need to find now two numbers that multiply to c and add to b, or multiply to negative 6 but add to 1. So here they will be 3 and negative 2, because 3 times negative 2 is negative 6, and 3 plus negative 2 is positive 1. So that means that this expression will factor to z plus 3 times z minus 2. So the plus 3 came from this number, the minus 2 came from the negative 2, with z just being the variable that was used in my quadratic equation. Now that's the factored left-hand side. This is still an equation, so we still have our equals 0. And now we can use the zero product property, because if I'm telling you that two things multiplied together equals 0, well, I know that one of the two or both need to equal 0. So I can write z plus 3 equals 0 or z minus 2 equals 0. And now I can solve both of these equations for z. So for the first equation, let's subtract 3 from both sides, and z is negative 3. For the second equation, let's add 2 to both sides, and z is positive 2. So I have two solutions here. Z can equal negative 3 or 2. And in my math lab, it will often ask you to separate answers with a comma, so you could write it like this. Okay, let's look at a second equation. 6x minus 5 equals 6 over x. Okay, well, this doesn't look quadratic because I don't see a quadratic term. There's no x squared term here, but we do have that fraction, 6 over x. And remember from earlier, the way we got rid of fractions was by identifying the LCD and multiplying all of our terms by that LCD. So here, our only denominator is x. So our least common denominator, or LCD, is x. So let's multiply all three terms that we have in this equation by x. When we multiply the first term by x, we get 6x squared. When I multiply the second term by x, I get minus 5x. And then when I multiply the right-hand side by x, they cancel out, leaving 1s. So I have 6. Let's put it in standard form by bringing everything to the left-hand side, so we have 0 on the right-hand side. And I can do that by subtracting 6 from both sides. And I get 6x squared minus 5x minus 6 equals 0. Now I need to factor this. And I cannot factor out a greatest common factor because no number goes into 6, negative 5, and negative 6 other than 1. So I could use a variety of methods. I'm going to use what I call the X box. So I'm going to draw an X just like we did on the previous example. So my A term is 6, my B term is negative 5, my C term is negative 6. But now, because A is not 1, what goes at the top of the X is A times C. Technically, we could have done that on the last one as well, but our A was 1. So 1 times C just gave us C. But here we'll have A times C, or 6 times negative 6, which is negative 36. And we will still put B at the bottom, which is negative 5. And we're still looking for numbers that multiply to our top number, or negative 36, but add up to negative 5. So for us, they are negative 9 and positive 4. Okay, but we can't go right to writing the factors yet. We're going to create a box. And in the top left box, the box is divided into 4 squares. In the top left box, we're going to put the first term, 6x squared. In the bottom right box, we will put the last term, the constant, negative 6. And in the 2 empty boxes, we will use the negative 9 and positive 4 that we found in our x combined with the x. So we will have, and it doesn't matter which one is what goes where, you'll get the same final answer in the end. So I'll put my negative 9 with an x in the bottom left. I'll put 4x in the top right. Again, we'll get the same final answer if you switch those around. So now I need to look at each row. If I look at the top row, 6x squared and 4x, what is our greatest common factor there? What can I divide out of both of those terms? And that would be 2x. Let's look at our second row, negative 9x, negative 6. What's our greatest common factor there? What can I divide out of both of those terms? 3. But because this left term is negative, we also will factor out the negative. So we've got negative 3 outside the second row. So I can do the same thing with my columns, or I can say, if I'm looking at my first row, 2x times what is 6x squared? That'll be 3x. 2x times what is 4x? That'll be 2. If I were to test it with the bottom row, negative 3 times 3x is negative 9x. Negative 3 times 2 is negative 6. Okay, now we have enough to write our factors. So 2x minus 3 will go in one set of parentheses. 3x and positive 2, or 3x plus 2, will go in a second set. And remember, this still equals 0. Now I can use my zero product property again. So I'll set 2x minus 3 equals 0, or 3x plus 2 equals 0. If I solve for x in the left equation, I'll add 3, and I get 2x equals 3. If I divide by 2, I'll get x equals 3 halves. In my right-hand side equation, I can subtract 2 from both sides, so 3x equals negative 2, and then divide both sides by 3, so x equals negative 2/3. So our solutions are 3 halves and negative 2/3. Now technically, because we have x in the denominator in our original equation, we need to make sure that neither one of those makes a denominator equal to 0. And if I put 3 halves in for x, that does not equal 0. If I put negative 2/3 in for x, that does not equal 0. So both of these solutions do work. Let's look at another quadratic equation. 2x squared minus 8x minus 5 equals 0. Okay, so here I'm going to use a different method. We're not going to try to factor this. Instead, let's solve this by completing the square. Okay, so our first step, and I'm hoping you watched my video on completing the square, is to divide everything by a. So a is 2. Let's divide everything by 2. 2x squared divided by 2, negative 8x divided by 2, negative 5 divided by 2 equals 0 over 2. Okay, so I have x squared minus 4x minus 5 halves equals 0. Next, let's move the constant to the right-hand side. RHS stands for right-hand side. So I'm going to add 5 halves to both sides, and I will get x squared minus 4x equals 5 halves. And I will leave that space there because I'm going to fill it in when I complete my square. Now we will add the term b over 2a quantity squared to both sides. And this is going back to our original a, b, and c, where a is 2, b is -8, c is -5. So I have -8 over 2 times 2 quantity squared that I'm adding to both the left-hand side and the right-hand side, because what I do to one side, I have to do to the other side. So I'm going to simplify this a little bit. I'm not going to square it on the left, but -8 divided by 2 times 2, or -8 divided by 4 is -2. So on the right-hand side, I know it's -2 squared that we're adding, but here I can simplify it. -2 squared is 4. So our next step is to factor the left-hand side, the LHS, and then simplify the right-hand side. So the reason why we added that term in step 3 is because now the left-hand side will become very easy to factor, and it will always factor in the same way. I can put one set of parentheses with a squared on the outside. My variable, in this case it's x, goes in my parentheses. And that term that I have that's squared, that -2, that -2 is going to go in the parentheses. So that left-hand side factors to x minus 2 quantity squared. And you can do that every single time, whatever values are in those positions. So my right-hand side, we're going to simplify. So let's work through this fraction simplification. So 5/2 plus 4, I need a common denominator. So 5/2 plus 8 over 2, because 4 is equivalent to 8 over 2. Now I have a common denominator, so I can add my numerators. 13 over 2. So I can put my 13 over 2 on my right-hand side. Step 5. Take the square root of both sides. So I can take the square root of the left-hand side and the right-hand side. So the square root of x minus 2 quantity squared is x minus 2. When I take the square root as a step in solving an equation, I need a plus or minus, and I've got the square root of 13 over 2. We are going to simplify the square root of 13 over 2 because we need to get a more simplified form. Although I believe my math lab will often accept it in this form. So I've got the square root of 13 over 2, which I can write as the square root of 13 over the square root of 2. I need to rationalize my denominator. My denominator is radical 2, so I'm going to create a fraction out of that term. So I'm going to multiply this by radical 2 over radical 2. I can do that because I'm essentially multiplying it by 1, which does not change its value. When I multiply the numerators, radical 13 times radical 2 is radical 26, and radical 2 times radical 2 is 2. So I have x minus 2 equals plus or minus the square root of 26 over 2. You do need to be careful with your radicals. So in my first red line, the radical went over the entire fraction 13 over 2. In my second red line that I've written, the radical just goes over the 26, and the 2 is not underneath the radical, or not included in what's underneath the radical. Okay, next step, solve for x. We need to get x by itself. We can do that by adding 2 to both sides. So when we have a plus or minus, often we'll put a term that's added or subtracted in front of the plus or minus. So x equals 2 plus or minus the square root of 26 over 2. And that's my solution. I have two answers. One is 2 plus the square root of 26 over 2, and the other one is 2 minus the square root of 26 over 2. Okay, let's look at another equation. So here I have pi x squared minus x minus pi equals 0. And I decided to illustrate this one because we're so used to our coefficients being integers, but we can have an irrational number like pi as a coefficient. It's still a number. So we're going to solve this using the quadratic formula. And you should know what the quadratic formula is. It is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So here my a is pi, my b is -1, and my c is -pi. So if I substitute those in, you'll see I always use parentheses when I'm substituting in, x equals the opposite of -1 plus or minus the square root of -1 quantity squared minus 4 times pi times -pi all over 2 times pi. Let's simplify. X equals 1 plus or minus the square root of 1 plus 4 pi squared all over 2 pi. Now, what's underneath the radical can't be square rooted, or at least not easily simplified. So this is our solution. And if sometimes my math lab will ask for a decimal, and you'll have to look to see what it says to round to, one of our answers for this will come out to be approximately equal to 1.17. The other solution is approximately equal to -0.85. Okay, let's look at one final example. Okay, this is a rational equation which will end up being quadratic. We're going to solve it just like we've done equations that have been similar to this so far. We're going to identify the LCD. In order to do that, I need to make sure all of my denominators are factored. So my first term is over x minus 2, and that's factored. My second term is over x plus 1, and that is factored. My right-hand side, I need to factor that expression. So I need to find numbers that multiply to -2 and add up to -1. So I've got my x's, and numbers that multiply to -2 and add up to -1 are -2 and +1. So that factors to x minus 2 and x plus 1. And you'll notice that here I have x minus 2's in my denominator, I have x plus 1's in my denominator. My LCD needs to have all the common terms. And since I don't have any x minus 2 quantity squares, I don't need to have two terms that have x minus 2 or two terms that have x plus 1. My LCD is just very simply going to be x minus 2 times x plus 1, that product. Just like before, we're going to multiply all of our terms, all three terms here, by our LCD. So I'm going to multiply my first term by x minus 2 times x plus 1, my second term by my LCD, and my third term by my LCD. So when I multiply the first term by x minus 2 times x plus 1, my x minus 2's cancel, and I'm left with x times x plus 1. When I multiply the second term by the LCD, the x plus 1's cancel, and I'm left with 2 times x minus 2. On the right-hand side, my x minus 2's cancel, my x plus 1's cancel. So technically, all I'm left with is 7x plus 1. Now I'll distribute. X times x is x squared. X times 1 is x. 2 times x is 2x. 2 times -2 is -4, equals 7x plus 1. Okay, now I know it's quadratic because I see my x squared term. I don't have any fractions with my x squared in the denominator. Let's start by combining like terms on the left-hand side. I've got my x squared. I can combine x and 2x, and that's 3x. And I still have minus 4 equals 7x plus 1. So to solve a quadratic equation, I'm going to bring all my terms to the left, so I have 0 on the right-hand side. So I will subtract 7x from both sides and subtract 1. And I can actually do it in the same step. So on the left, I have x squared minus 4x minus 5 equals, on the right, I have 0. So I'm going to factor this using my x. Negative 5 is my C term, so it goes at the top. Negative 4 is my B term, it goes at the bottom. Numbers that multiply to negative 5 and add up to negative 4 are negative 5 and positive 1. So I can fill in my parentheses with x minus 5 and x plus 1. I do need to use the zero product property and set each of the factors equal to 0. So either x minus 5 equals 0 or x plus 1 equals 0. Add 5 to both sides in the first equation, x equals 5. Subtract 1 from both sides in the second equation, or x equals negative 1. But I do need to check by seeing if x equals 5 makes any of the denominators 0. So if I put 5 in for x and x minus 2, that first denominator, does 5 minus 2 equal 0? No. Does 5 plus 1 equal 0? No. And if neither one of those equals 0, it's not going to make the product equal to 0. So x equals 5 is a solution. Let's check the second one. Does x equal negative 1 make a denominator 0? So if I put negative 1 in for x in the first one, negative 1 minus 2 does not equal 0, so it's fine there. But in the second denominator, negative 1 plus 1 does equal 0. That means that x equals negative 1 is not a solution. It is extraneous. And our only solution here is x equals 5.